So one of the things, from past knowledge, I'm looking at this, and I know there's a glare right there, correct, for this side of the room. Is that correct? Oh, I'm looking at the camera. Looks like there's one here, and then there's one right there. Okay, but that's just what I see on the computer. Okay, so with that, should there be a glare, you're saying it's in a different spot. Okay, you might have to move. You might have to adjust your neck, your head, trying to see what it is we're actually trying to write down. So a lot of these questions, okay. This is some of our special topics, if you want to call it that. The idea of, we had watched parts of what was called the brain, okay, and then we moved on to a segment. It was the brain, who's in control, and the other one was about decision making, okay. So the second one about making decisions, we talked about that yesterday. I really don't know if I put much stock into that. The author or the narrator or host had said, find a word and a page in a book, and the neuroscientist picks out that same word that she picked out. I'm skeptical about that. But again, it was on the show Nova, so does that make it accurate? Well, I would like to think so. But regardless, I would like to think that we can see some reasoning. These are I think, good questions that we had wrote down through the progression of this video. And then we talked about them on a daily basis. Okay, because when we look at this, what part of the brain causes fear? Okay, so even though when we talk about different types of emotions, which there are at its root maybe 5 basic emotions, okay? So what might they be? Anger is 1. Sadness is 2. Fear is 3. Joy is 4. Now you're just thinking inside out. That's what we're doing, right? Then I think there's one more, starts with a D. Disgust. Okay? Is there anything past those 5? Okay, and I think what's really strange about that is, does sadness have its place in our life, do you think? And I think to answer that is, you might be thinking, why not just have joy and happiness all of the time? Well, and I think there's perhaps a couple reasons for that. And it would perhaps tie into, okay, this part of the brain right here, okay? That dealt with, and we'll come back to that. We're not just jumping around. Do you remember, it was the gal that was going to do cliff diving, okay? And the scientist had said the thrill of the reward was more powerful than her thought of fear. Okay? Because if it was the other way around, if she's too scared, I'm not going to have that thrill. I don't want that fear of not partaking in that and not jump off the cliff. Okay? Because her sensitivity to dopamine it's actually pretty high. But it's just the idea of, what are we doing? Oh, hey, that's a good idea. You're just being a good friend. Did it work? Hey, you're not hiccuping.
You're supposed to hold your breath. That's what I was not think about it.
Okay. Is any of this working? It's funny how everyone likes to give you advice, right?
We're just trying to help and follow a friend out.
Yes, you are.
I think they're gone now.
See? Is it because you didn't think about it, or because you have such a good lab partner, or is it good advice? Okay. Well, you're not turning blue, so I think we're okay. All right. So getting back to me, what makes sense is, if we always had happiness, always had joy, we're always happy, your happiness would start to become desensitized because you don't know what it's like to have failure, to have not so much fear, but and I think there's some validity to that. I think there's some reasoning to it. Just like that same person who's doing all this cliff diving, eventually, probably the sensitivity to her dopamine is probably going to start to diminish until maybe come up with an activity that's even a little more dangerous. Because just like we said, some of you have done skydiving in here. Am I imagining things? Or I thought someone had raised their hand and said, yes, I have done skydiving. Okay. So was there ever any thought that I don't know if I want to do this?
Well, I didn't want to chicken out.
Well, I think that's perfectly fine. What? YOLO? Oh. I did not catch that.
Yeah.
Mr. Wagner, did you catch that?
YOLO?
Yeah.
Yeah. Do you know what it means?
They just told me, so yes.
Yeah, okay.
Yeah,
I thought you didn't catch what it meant. I see.
Well,
It's an old phrase, I think.
really?
Like, old meaning 2012.
Okay. So, anyway. So, does fear have a place in our life too? And that also, okay, these two can also work together. This fear and these dopamine receptors, okay? Not the idea of, oh my gosh, okay? Let's cause some fear here. Who's picking on who? Okay, so she's got the axe, so she'll just say, Caitlin, trust me. This will be fun. I'm going to hold this axe like this, and then right at the last moment, I'm going to stop. And I'm not going to chop your head off. But you two are friends, though.
It'd probably slip out of her hand or something.
Oh, you're not that uncoordinated, are you?
Me and Anna should switch spots on this thing.
Who should? Okay. Oh, okay. All right. So, scary movies, is that fear? I would say that it is.
Yeah, for sure.
Okay. I just heard some elementary students or middle school, they're 6th grade, I think. Five Nights at Freddy's or something like that. Is someone looking at that saying, I've got to see that? I know you probably are thinking that, or you think it just looks dumb. Because you're a scary movie person.
I am.
Okay? But that's not on your list.
A lot of my friends have gone and seen it, and they liked it. It did it really intrigue me.
Okay? So, one of the things I think about that I can't explain, what is it about the scary movies? Is it the thrill of does it give us joy that our dopamine receptors are sensitive to that and we enjoy that? Or is it the idea of feeling your heart rate go up? I don't have an answer for
Yeah, I
that.
think it's the same idea, but less so than skydiving.
Okay.
Yeah.
All right. So regardless, what part of the brain causes fear? It's actually part of your brain stem. It's a specific part. It's not the pons, it's not the medulla, it's not the midbrain. It sits right on top of the pons. It starts with an A. Say that again. Amygdala. That's right. I didn't know whether to say correct or right, so I think I said them both at the same time. So, yes, the amygdala. Oh, that's not right. Okay. I believe that is correct. All right. Yes, it is your amygdala that does that. But again, fear has its place, okay? Because it's something that keeps us alive. Because if it's something that we're fearful of, okay, chances are that's going to keep us out of harm's way. Okay. So what part of the brain works outside of the limbic system? So first of all, you'd have to know, well, what is the limbic system? It's a very specific part of the brain that starts the letter D. Did they come back? Because I saw you do this. Did they come back, the hiccups? Oh, okay. Yes, the diencephalinon. It does control your emotions. That's exactly right. But in this case, if it's working outside of the limbic system, it can't be these two structures. Because what is it that makes up your limbic system? Thalamus and hypothalamus. Okay? So if it's something that works outside of your limbic system, it's another part of the brain. It's what we do for reasoning to think out a stressful situation. The frontal cortex. That's right. Now, we talked about that before. Should it be prefrontal cortex or just the frontal cortex?
It's prefrontal cortex, but yeah, prefrontal cortex.
Okay, the prefrontal cortex. So there we go. Okay. So on this part, okay, which part of the brain is associated with secreting hormones? Now you got to remember, we can really simplify this, okay? Here's your central nervous system, okay? So that gets split into going this direction and gets split going into that direction, okay? So, actually I'm going to run out of space. So I'm going to move this over, okay? So what's going to be on one side of our central nervous system? Okay, so you're not wrong, but you were first. Okay, so here you have your autonomic nervous system. Okay, so then on the other side you have said what? The somatic nervous system. Okay, now it's a little tricky if you just say SNS. Does anyone think they might know why that would be? Because there's two of them. Is there two PNSs? Yes, there is. Okay? So once we've talked about this part of our nervous system, this side is going to control what? Just in general. Very simple. You're playing with your hair. You are doing this. We're scratching our face. We're playing, I got a mustache, right? I can't do that. This is too. That's what it comes to mind. Every time I see something under the nose, I think, they think they got a mustache or what? No, but that's what that comes to mind. Okay. So here is skeletal muscles on this side. Okay, then what is on this side of our central nervous system? It's autonomic, but what? Okay, you're not wrong, but those smooth muscles are controlled how? On the autonomic side, I get that. So we want to break this down even further. Okay, remember we said there's two PNSs and there's two SNSs. Okay, so here was one of them. What is the other SNS that goes under here? Sympathetic nervous system. Why is that important? Because what does your sympathetic nervous system do? It can. You're not wrong. Okay, so anytime you're in a stressful situation, okay, it's associated with this hormone that causes your heart rate and respiratory rate to go up. And adrenaline does that. Okay? But is that secreted on, or is that secreted because of this side or that side? The SNS or PNS? Right. Your sympathetic nervous system It deals with stressful situations. Okay? That's what causes the hormone adrenaline to be released. That's why they call it the flight or fight response. Then this one, on the other side, we had talked about this type of action with your hormones. Okay? Sorry? Yes. The waves going up and down. So if it's not the flight or fight response, we said in general it's possibly what? Rest in something. Rest and repair. So this is the flight or fight. That's the rest and repair. Now, one of the things that when we say rest and repair, we said there is a hormone artificially that you can consume, which is what? Now, someone in here, I don't mean to be it's not funny, but to me it is. It's not that someone might take melatonin, but someone made the comment that they know someone who takes a lot of it. Okay? Was that, and don't say any names, but was that somebody in here or someone, was it someone that you know? Okay? Now, so if we've established it's someone that you know that's not in here, okay? What happens when we might say, okay, they needed to fall asleep. They took 1 or 2 melatonin pills. We'll just say 2. Okay? So if they're taking a lot, well then these 2 melatonins must not be working. So why would they take more? Well, they're not working because the sensitivity to it is starting to diminish. So it takes more to do that in order to have that rest and repair division take place. Because what do you suppose melatonin does for us? Yes, it causes us to sleep, so it's causing your rest and repair division to slowly take into account to come back down on that wave. Okay? That's why we say going up and down, like you said, the wave. The sympathetic nervous system causes you to go up. Then other hormones like melatonin, for instance, I just use that as an example because your consciousness, you can slowly feel yourself drift off to sleep. You might have one final thought, and then all of a sudden you might think, oh my gosh, I just fell asleep. Now my alarm clock's going off. Okay? I'm sure we've all experienced that you had some final thoughts, all of a sudden you hear beep, 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 beep. Okay. All right. So then, which part of the brain is associated with secreting hormones? Is it the somatic or this side, the autonomic? It has to be the autonomic because you do not want to have conscious control of secreting those hormones. Okay? So that's why it has to be the autonomic side. Okay? So we'll just put A and S here because it can be either one of these two here. All right. So which part of the brain is responsible for reasoning? In other words, to logically think yourself through a stressful situation. Some of these get used more than once. Yes. So same thing as what we have here. So I'm just going to put prefrontal cortex, or PFC. Okay? Okay. So now, the densest part of the brain for dopamine, which is a way of, dopamine is a feel-good hormone, okay? Because that's what you're releasing when you are jumping out of planes, jumping off the cliff, going to scary movies. It's going to be something like that dopamine is actually released. So in this case, it's called the corpus striatum that does that. And if you just want to know it as striatum, that's fine too. Okay. So this whole question you could say is based off of that term right there, empathy. Okay? So going back to our thrill seekers, why might you want to take that action? Do you have empathy or no empathy?
You would get mad, do it, and then feel bad.
Oh, so you do have empathy. Because when you empathize with someone, you are looking at something from their perspective. So which part of the brain is underdeveloped in psychopaths? Okay, that's not what we're referring to here. We're just going back to a prior example and what empathy is, because they lack this empathy. Okay, and oddly enough, it's not a part of the brain that you would think of. It's more so what causes fear. And that was what from up above? It's your amygdala that does that. Okay? Okay? Then finally for today, which part of the limbic system acts as a key to our emotions? So now, you have to know where the emotions are coming from. Well, it's the limbic system. Okay? So when we look at that, you have one of two choices. Or, so you got a 50-50 chance. Who says hypothalamus? Who says thalamus? And the rest really aren't paying attention. It's actually your hypothalamus. Okay? Hypothalamus. Now, that is where we will stop today. Okay? So these questions that we're going over, okay, is going to be part of the exam on Friday. Okay? That's why we're doing this today. So we have today to go over it. We have tomorrow to go over it. And then you'll have time Thursday night or something to that effect, because that will be on Friday. Also, on Friday, you will have an interpretation in how this works. We have this in the drop folder, and we've seen this before. It's how you correlate what's actually happening. Okay? That is vocabulary and general questions over chapter 10, which was cells of the nervous system. Okay, and then I think we'll put the cranial nerves on Thursday. So the order from front to back. Okay, so how many of you would be comfortable with that? I said I didn't know if we're going to do functions at all, whether it's sensory, motor, or mixed. I think we'll ditch that, because if you already know it, then that information is going to stay with you. Okay? I think there's a better chance it's going to stay with you as opposed to, yeah, let's just force that extra bit of content on you. Then by Sunday afternoon, you're going to say, huh, what was sensory? What was motor? What was mixed? Okay? So what we want you to do is interpret on Friday, okay, how this is actually taking place. And like I said, this is in the driver. At least I believe it's still there. And this guy right here, okay? So it's set up just a little bit differently from what we had seen earlier. Our diagram, we put the central nervous system here on top. Here it's just on the side, just for convenience sakes, okay? So with that, what you are actually describing is, okay, how do you know, okay, you see what looks like a hole in your opponent's defense, okay? So maybe some of you do some scouting with your hitting, or sometimes you just try to do some of them tips that finds the holes, weak spots. What's the proper way? You find the hole in the defense, but how do you know how to do that? Okay? Well, how do you know whether that ball is going to be, it's a guess, but your best interpretation is, how do I know whether to hit the ball or whether to let it go? Well, besides your teammates, you need to make that decision right now. Didn't we say height, though?
Yeah.
So if it's eye level or shoulder level, I remember that part of the conversation. Which would it be? Okay. If it's above your head, let it go. So you need to know, make that decision right now. Okay? So what might be some special receptors, okay, that's going to send information to your brain? Because why is it not this side? Okay? Because we do have these same visceral receptors on this side, because you are moving skeletal muscles. We're not worried about adrenaline or anything like that. So a stimulus has to be sent to your brain, because I need to decide, am I going to let this ball go, or am I going to try to hit it? So you have this information that's being rushed, flooded to the brain. It makes a very quick outgoing response to your skeletal muscles, okay? And then I would say, out of every 10 times, you're probably right 9.5 times. Because the reason we said, how can you be right half a time? Well, the more data that you collect, you can probably get a fraction from that. So I would say that 95% of the time, you're probably right. I think that's probably a pretty good percentage to go by. All right, so we will stop there for today, and we will pick up with this content tomorrow. We'll catch up to you next time.